Is Chapter 13, Bruner's Constructivist Theory. I have here first the objectives. Describe the development of the child's ability to represent knowledge. Second is explain how the spiral curriculum works. First, we need to know who is the person behind this theory. The person behind this theory is Jerome Bruner, a cognitive psychologist created a theory of development. Jerome Bruner was one of the first proponents of Constructivist. A major theme in this theory of Bruner is that learning is an active process in which learners new ideas or concepts based upon their current or past knowledge. Jerome Bruner, born in New York City on October 1, 1915. He received his AB degree from Duke University in 1937 and his PhD in 1947 from Harvard. So he was on that faculty, the development of psychology at Harvard from 1953 to 1972. Bruner's theory of constructivism. Constructivist theory places emphasis on the development of self-learning, or it is a student-centered. Learners are equipped with prior knowledge and understanding to conduct meaning of what they learn. So now, let us move forward to its main concept. In this research on the cognitive development of children, Jerome Bruner proposed three main concepts of representation. First is the inactive representation. At this earliest age, children learn about the world through actions on physical objects and the outcomes of this action. Children represent objects in terms of their immediate sensation of them. This learned through movement or action at the age of 0 to 1. For example, a child might show to others that he knows how to float in the water without explaining it. Number 2, the iconic representation. This second stage is when learning can be obtained through using models and pictures. The learners can now use mental images to stand for a certain object or event. For example, like kana makakita sila sign nga kanang naa sa mall nga step here, so musunod pud sila ana. And then the third is the symbolic representation. In this third stage, the learner has developed the ability to think in abstract terms. This uses symbol to encode knowledge. The most common symbol system are language and mathematical notation. For example, student tells his teacher that he knows something by writing an essay or journal that is in the form of words that teachers utilize to bring together concrete, pictorial things, symbolic activities to facilitate learning. Before children can comprehend abstract mathematical operations, teacher can first have the numbers represented inactively and then iconically in pictures. Children can later on handle number concept without concrete objects and only with numbers and number sign. So now let's proceed to the spiral curriculum. Bruner stressed that teaching should always lead to boosting cognitive development. Students will understand the concept if teachers plan to teach it using only teachers' level of understanding. Instruction needs to be anchored in the learner's cognitive capabilities. So in a spiral curriculum, teachers must revisit the curriculum by teaching the same content in different ways, depending on students' development level. So, meaning to say, spiral curriculum teachers play a vital role in understanding the information to be learned in an organized spiral numbers. So, the teacher should not only level by his or her understanding, and by that it can build upon what they have already learned. So, in K-12 curriculum, the spiral progression is a mandate section 5. Curriculum development of RA 10533 states, the curriculum shall use the spiral progression approach to ensure mastery of knowledge and skill after each level. So as applies in math, algebra, geometry, statistics, and trigonometry concept from kinder to grade 10. In science class, biology, chemistry, and physics concepts can taught taught from grade 3 to grade 10. Algebra is taught in the first and second year, geometry in the third year, statistics and probability and trigonometry in the fourth year. In science, integrated science is taught in the first year, second year biology, third year chemistry, and the fourth year is physics. In the spiral progression approach, concepts are revisited again and again as you go up the grades, because this supports mastery of concepts. Next are the principle of instruction stated by Bruner. Number 1, instruction must be concerned with the experiences and context that makes the students willing and able to learn. Number 2, instruction must not be structured so that it can be easily grasped by students. And the last is instruction should be designed to facilitate extrapolation and or fill in the gaps. So we have here the discovery learning. Discovery learning refers to obtaining for oneself. The teacher plans and arranges activities in such a way that students search, manipulate, explore, and investigate. Students learn new knowledge relevant to the domain and such general problem-solving skills as formulating rules, test, and gathering information. So we have here the classroom example. An elementary teacher might use guided discovery to help children lead animal groups like mammals, birds, reptiles, rather than provide students with the basic animal groups and example for each. So, as a teacher, mag-provide sila og kanang mga pictures para kanang dili ma-get bored ang mga students. In high school naman, a chemistry teacher might use mystery liquids and have students discovery and elements in each. The student could proceed through a series of experiments designed to determine if certain substance are represent in a sample. So, in high school, kanang ang mga student is kanang engage na sila through experiments. Next, let us move forward to the Bruner 1966 state that a theory of instruction should address four major aspects. Number 1, predisposition to learn. It introduces the idea of readiness of learning. Bruner believed that any object could be taught to any stage of development in a way that fits the child's cognitive abilities. He believed that learning and problem solving engage out of exploration. Part of a task of the teacher is to maintain and direct a child's spontaneous explorations. So, second is the structured knowledge. The ways to which a body of knowledge can be structured so that it can be most really grasped by learners. Third is the effective sequencing. No one sequencing will fit every learner, but in general, the lesson can be presented in increasing difficulty. Sequencing or lack of it can make learning easier or more difficult. So sequencing, according to Bruner, instruction should lead to the learner through the content in order to increase students' ability to grasp information and transfer what is learned in the general sequencing. So the last is the reinforcement. Rewards and punishment should be selected and phased appropriately. He investigated motivation for learning. And the last part, we have here the categorization. Bruner gave much attention to categorization of information and the construction in interval cognitive maps. He believed that perception, conceptualization, decision-making, and making inference can all involve categorization. Categories are rules that specify four things about objects and four things. The four things are: first, the critical attributes, required characteristics for inclusion of an object in a category. For example, for an object to be included in the category car, it must have an engine, four wheels, and a possible means of transportation. The second rule prescribes how the critical attributes are combined. The third are assigns the third rule assigns weight to various properties. For example, matawag hapon siya car bisan pag wala siya tire, and if it was used for hauling cargo, it would be shifted to a different category of truck or perhaps van. The fourth rule sets acceptance limits and attributes. Some attributes can vary wildly, such as color. For example, a vehicle with only two wheels would not be included in car. There are there are several kinds of categories. The first is the identity categories. Categories include objects based on their attributes or features. Second, the equivalent categories. Equivalent categories can be determined by affective criteria, which render objects equivalent by emotional reactions. Functional criteria based on related functions. For example, a car, a truck, a van could all be combined in an inclusive category called motor vehicle, or by formal criteria. An apple is still an apple whether it is a green, ripe, dried, and etc. The third, and this is the last category. Last is coding system, are categories that serve to recognize sensory input. They are major organizational variables in higher cognitive functioning. And that's all. Thank you.